So hi everyone, in this chapter we're going to talk about a new we're going to talk about the chemical composition. So we will basically will be focusing on the composition of the matter, right? Why is important to know the composition, how many atoms we have in that matter, and what are the different types of atoms we have in that like mixture of matter, right? So we're going to talk about the composition. So let's begin about a question, right? Why is the knowledge of composition is important? Why is important, right? To know the component, what matter is made up of. So as you know, everything is in nature is either chemically or physically combined with other thing. So most of the thing in nature are mixture, right? So let's take an example. If the doctor tells you that you have to take just 1 gram of sodium per day in your diet, so how many grams of sodium chloride, which is a salt, NaCl, you need to take, right? Because you cannot take just sodium, right? Just 1 gram of sodium, you cannot take just 1 gram and just eat that thing. So you have to calculate how many grams of salt, NaCl, that has the sodium in it. How many grams of NaCl you need to take so that you can get the required amount of sodium, which is 1 gram in your diet, right? So that you have to know the composition, right? How many grams. Similarly, the amount of hydrogen in water to make hydrogen fuel. Let's say if somebody wants to make a hydrogen fuel, how much amount or how many grams of hydrogen you need to mix with water to make that hydrogen fuel, right? So that's why the composition is important. How much part of one element is made or giving to the all over mixture, right? All over the component of the mixture. So you can say this thing. So let's take an example. So let me give you one example over here. Yes, it's here. Just give me a second. Okay, so let's take an example. If you go to an hardware shop and if you want to take, let's say 2500.00 nails, if you need to buy this number of nails, and so how would the shopkeeper will give you this number of nails? There are two ways. One, he or she is going to calculate, right? 1 2 3 4 5 6, right? All the way till 2500, right? But what's the problem with that? It will take a lot of time to calculate 2500 nails, right? It's a wastage of time. So there's a second way. The shopkeeper will count or will determine how many nails you have or how many nails shopkeeper is giving to you by weighing them. So shopkeeper already know if he weigh, just give me a second in here. So shopkeeper already know, let's say if it weighs 3 pound of nails on the weighing balance, if you put 3 pound of nails, right? He knows that if you weigh 3 pound, let's say he has 300 nails in that, right, weighing balance. So to get 2500 nails, how many pound or nails he has to weigh, right? So you have to calculate. So this is an easy way instead of counting all the way till 2500. So the time you see over here, this is an equivalency, and we already talk about the dimension analysis, how to make conversion factor in chapter number 2. That's why that chapter is very important, right, to understand, because all of them are basically depend on that chapter. So we're going to use the same concept, and what we need, how many pound, right, the shopkeeper need to weigh to get this number of nails, right? So we need pound. Pound has to be on the top. 3 pound over 300 nails, and then you have to just multiply what is the given number of nails that you require, right, or shopkeeper need to give to you. So it is 2500. nails. Nails get cancelled, and if you divide, multiply, 0 0 get cancelled, 3 get cancelled. So when you solve it using your calculator, you will get around 25 pound of nails. So he just have to weigh 25 pound of nails to get that 2500 nails for you, right? So that's why that's why it's very important to get some information or get some number, right, and convert that number into a spatial number. In this case, we already convert a 300 nails into a number called 3 pound in the weighing term, right? So similarly in matter, everyone know, right? We know that matter is made up of atoms, right? All these are atoms. So if I say how many atoms you have in this matter, it can be billions, zillions, right? But if so, we cannot count each and every atom within the matter. Is impossible, or it's very difficult to count. So scientist has provided a spatial term for a limited set of number. If you have that number, that means you have that is spatial term, right? So let's get back to the slide and I'll tell you what I'm talking about. Okay, so let's go over here. Okay, so that is spatial term we call as mole over here. So the scientist has provided a term called mole, and whenever you say a matter is consist of 1 mole of thing, that means that has 6.022 times power 23 things, right? So if matter is made up of atom, so I can say 1 mole of that matter or that element has 6.022 times power 23 atoms if we're talking about element, because element is made up of atom, right? So you have to remember this number, 1 mole equal to 6.022, right? And because this is an equivalency, we can make a conversion factor, right? And this number we call as Avogadro's number. So if from now on, if I say Avogadro number, you need to know I'm talking about a mole equal to this number of thing, right? So this is called Avogadro's number. So now let's try to solve a couple of problem on this Avogadro's number, and we'll see how we can use that definition to solve the problem. So let's try solve. Okay. So the first question says a silver ring contain 1.1 times 10 to the power 22 silver atom. How many moles of silver, right? So in this case, it says you have a ring and that ring has a lot of atom, right? So the atoms are already provided to you, which is 1.1. So if I tell you you have this number of atom, how many moles, right, that ring has? So we know the relationship between moles and atom or thing. 1 mole equal to 6.022 10 to the power 23, right? 23 atoms. Because why atoms? Because we are talking about silver, which is Ag. This is element in your periodic table. An element is made up of atoms. So a mole we are talking about, I can say 1 mole of silver atom, Ag element is this number of atoms. So the time I make this equivalency, I can make a conversion factor, moles. We need moles, so moles has to be on the top. 1 mole of silver atom Ag over 6.022 10 to the power 23 of silver atom, you can say Ag atoms, right? Ag is a symbol for silver. And then once you make this conversion factor, just multiply with your given number. What's your given number? How many atoms you have? 1.1 times 10 to the power 22 silver atom again, that is provided to you, right? Silver atom. So before we can solve this problem, we can estimate the number of moles should be less than 1 or more than 1. Whatever the answer we are going to get over here, it should be more than 1, 1 point something, right? 2 point something, or less than 1. means point 0 point something. So we can predict it by seeing this number. How? Because we know a mole is this number and the given number is less than this number, right? So that means whatever the number of moles we're gonna get for this number of atoms should be less than 1. Makes sense, right? Because this number is bigger, and if the bigger number is 1 mole, the smaller number should be less than 1 mole, right? So if you divide these two numbers, solve using your calculator, 1.1 times 522, you will get a bigger number, right? Answer something like this, 1.8266 10 to the power negative 2 mole. Because silver atom will get cancelled. The only unit left is mole, right? We already did this thing. Now we got the answer, but this answer is a little bit big. How many six-figure number you have over here? You have 5, but how many we actually need? We have to see in the given number, how many significant number we have. We have two significant number, right? We already talked about how to find the significant number or figure for any scientific notation. So we need 2, this is 1, this is 2, this is less than 5, so it won't increase by 1. So your final answer will be 1.8 times 10 to the power negative 2 moles. This is your final answer for this thing. And if you want to convert this scientific notation into a standard form, you can do that too. So it should be 0.018 mole. So this is your standard answer without a scientific notation, and this is your answer in scientific notation. So both the answer are right. So it's up to you, or depending on the multiple choice question, whether you get your answer choices in scientific notation or standard form, right? So you should know how to convert one form into another form, right? So that's what that previous knowledge is important for you, right? So this is the way you solve the problem, this one. Okay, so now let's try to move it to the next question over here. Just give me a second. Okay, so now let's try to do the second problem. Calculate the number of atoms in 2.45 moles of copper. So in this problem, what we need to know? We need to know number of atoms if moles is given, right? What's the previous problem? Atoms were given, you have to calculate moles. So in this problem is vice versa, opposite. So it's again the same technique, right? So let me solve it for you guys fast. So let's make a solution box. I didn't make in the last example. Let me make it over here. What we need, number of atom. So let's put number of atom. We need atom, right? Atoms. And what is given? Moles are given. That's how we make solution map. Is there any relationship between moles and atom? Yes, we know 1 mole equal to 6.02 10 to the power 23 atoms. So there is a direct relationship. We can go directly from moles between the two boxes. We don't need any third box in between, right? And once we make the box, we can make a conversion factor. Yes, I can write 6.022 times 10 to the power 23 copper atom. Copper is your Cu. Cu. This is your copper atom over 1 mole of copper. This is Avogadro rule, right? And once you make the conversion factor, you can write your given number, which is 2.45 moles of copper, MOL of copper. So now you have already set the problem. You have to cancel mole of copper with a mole of copper, and then you need to solve your calculator, and then you will get your answer around 1.48 times 10 to the power 24 atoms of copper. So this will be your answer. Why this is your answer? It has 3 sig fig number, and then 2.45, the given number has 3 sig fig number. That's why we need a 3 sig fig number in our answer. If you remember why we are not using a significant number from this conversion factor, I already said this is an exact number equal, right? We cannot use to count how many sig fig number we have to have in our answer. We have to just see the given number, right, in your problem. So we already did two type of question, moles to atom and atoms to moles, how you normally convert, right, using the Avogadro's number. So now let's see if we have some more problem in here. So these are two problems that we discussed. So you can solve as many problems for your practice, right? From your textbook or or from the worksheet that I provided to you. Okay. So till now we just work on the relationship between moles and atoms, right? 1 mole equal to 6.02 times per 23 atom. But now we need to know, is there any relationship between moles and mass? Yes, there's a relationship between moles and mass. Let me write what's the relation. It says 1 mole of an element, 1 mole equal to, if you're talking about element, you can write atomic mass. Atomic mass. And what is atomic mass? Is the mass for an element given in the periodic table, right? So you have atomic number and atomic mass, if you remember from the previous chapter. Or you can say molecular mass. So make sure you remember this thing. So atomic mass, let me show you. So this is the relation between mass and mole. And we already talk about the previous relation, which is this 6.022 10 to the power 23. We already learned this thing, right? Atoms. So the thing is that 1 mole is equal to 6.0 10 to the power 3 is a thing, right? If we're talking about element, then we write atoms. If we talk about compound, right, or molecule, we convert or remove atom from molecule. I'll talk about more, but this is an important difference. You have to know atomic mass, molecular mass, atoms and molecule. So we're gonna go again on this topic, but make sure you know these two concepts, how moles are related, right? So can I say mole is the central component? And if you know the mole, you can convert that mole into a mass or atoms, or you can say molecules. Right? If you know the moles, you can convert atom in molecules from Avogadro's number, right? This is a relation between atom and moles, or atoms and moles, and or molecule and moles. And I can say, if you know the moles, you can also get the mass from the first relation. I can make a conversion factor from this relation. So if you know the moles, you can go both ways. Convert moles into grams, or mass, which is in grams, or atom and molecule, right? Or if I have a mass, I can convert that thing into moles using the same relation. And if I have an atom, I can convert into a moles. So you have to know this pathway: mass, mole, atom, or molecule, and they are interconverted, right? You can convert each of them, right, between them. So if you have a mass, you can convert into mole. If you have a mole, you can convert into atom, and vice versa. If you have an atom, moles, mass. The only thing that you need to remember, if the mass is given in grams, let's say you have 10 grams of sodium, how many atoms you need? How many atoms you have in that 10 gram of sodium? you have to pass through mole. There is no relation that can directly go from mass to atom or molecule, right? So, and then you have to use these two relations. So this is your main thing for this chapter, these two relation and this pathway, mass, mole, atom, atom, mole, mass. You have to follow this pathway. If you know these two things, you can solve any problem from this chapter, right? Okay. So let me clear this thing over here. Let's say, let me give you some example. If I say I 1 mole of sodium, Na, is a group 1 element, right? Let's see where the sodium is. Let me show you. Okay, so this is your sodium in here, right? This is your sodium Na. This is your atomic number. The bottom one is your mass number, you can say. So this is 22.9 and we usually take 23. You can take 22.92, right? This is atomic mass unit, or you can write grams, right? So this is your mass number, 22.9 grams. So I can say 1 mole of sodium is how many grams? Around 23 grams. Similarly, if I say 1 mole of nitrogen element, how many grams? Because from the relation we know 1 mole equal to the atomic mass, 14. Let's do one more last. 1 mole of neon, Ne. Where do you have neon? Is here, Ne, which is 20.17, you say, or 20.2. But yeah, you can take this thing, or 20 grams, right? So if you have the periodic table, you can get the mass, atomic mass from the mole, right? Okay. So this is one way. This is from the, now let's talk about a molecule, how to get the molecular mass. As the name is saying, molecule, molecular mass. So let's say if I have 1 mole of water, H2O. Can you figure it out where the H2O is in your periodic table? No, because this is a molecule. Molecule is a combination of 2 or more element or atom. What you have here, you have 2 hydrogen atom combined with 1 oxygen atom to get 1 molecule of water. H2O is a molecule, right? It's not an element. So how to get the, then if we talk about molecule, then the atomic mass is not there. This is a molecular mass. So how to get the molecular mass? So molecular mass will be, I have 2 hydrogen atom in here plus 1 of oxygen atom. So you can calculate like this, 2, and each hydrogen atom is how many grams? Is here, around 1 grams, you can say, plus 1 time, you have 1 oxygen. How many grams each oxygen atom? 15.99, you can say 16, right? Close. So that is 2 grams plus 16 grams gives you 18 grams. So I can say a mole of water is equal to 18 grams of water. This is how you normally calculate a molecular mass for molecule, right? I'm again emphasizing, for molecule, you have to calculate individual mass of individual atom and then combine together. Let me give you one more example and then we'll go to the question. If I say 1 mole of H2SO4, how many grams of H2SO4 you have in there? So you can see this is a molecule, right? Made up of more than 1 or 2 atoms. So how many hydrogen you have over here? 2 hydrogen. Each hydrogen is 1 gram. So 1 into 2, 2 grams. How many sulfur you have? 1 sulfur. How many gram? How many was the atomic mass of each sulfur? Where you have sulfur? Here, around 32. So let's write 32. So it's 32 grams. And you have oxygen. How many oxygen you have in H2SO4? You have 4 atoms of oxygen, right? So 4 oxygen, and each oxygen is 15.99. We can say 16. So I can say 64 grams. And then if you add all of them, you will get around 8, 9, 98 grams. So I can say 1 mole of H2SO4 sulfuric acid is 98 grams, right? So this is how you normally calculate a molecular mass, right? So apply the same technique to figure it out the molecular mass for any molecule using the periodic table, right? Okay, so now let's get back to the PowerPoint. Okay, so now let's try to solve some problem over here. So it says calculate the moles of sulfur in 57.6 gram of sulfur. So what is sulfur? Sulfur is atom element, right? So, and this is gram, 57.8 grams. So which rule we have to use? We have to use mole and grams because we need moles, the second relation. So, so I can solve this thing like that. I know 1 mole of sulfur is S. 1 mole of sulfur is equal to atomic mass of sulfur, and we just saw from the periodic table it was 32 grams, right, from the periodic table. So we need moles. So what we need, we have mass, MASS, mass is given, and we need moles, and we can go mass to moles, right? Because this is relation mass grams, because mass is normally calculated in grams. The unit is grams. Right? What's the conversion factor between mass and moles? I can say 1 mole of sulfur over 32.0 gram of sulfur. Right? And the time I made as the conversion factor, you can just write the given number over here, which is 57.8 grams of sulfur. So grams of sulfur get cancelled, and the only unit left is mole of sulfur that we needed, right, in the problem. So if you divide these two numbers, you're gonna get around 1.81 mole of sulfur. Right? And how many sig fig number we need in our answer? We need 3, because this is the required significant number, right? 3. So this is the right answer for your this problem, 1.8 moles of sulfur. And it makes sense. You can cross verify it. Why the moles is more than 1? Because a mole of sulfur is 32 grams. And how many grams you have? More than 32, which is 57.8. So it should be more than 1 mole in your answer, right? So this is how you normally cross verify if you need to cross verify whether you did the right way or not. Okay. Now let's see if we have more problem in here. Okay. So this will be your homework over here. Calculate the moles of carbon in 0.26 gram of pencil lead. And I can write over here, right? Let me write. Over here. Okay. So let me do this question right for you, because we are just starting a thing. So let's do it again. Calculate the moles of carbon in this gram of pencil lead. Lead is the black portion of the pencil that you use to write on the paper, and it is made up of carbon, right? So what we need to, which relation we have to use? We again have to use relation between mole and grams, because we need moles, grams are given. So 1 mole of carbon, we know it's around 12 grams from the periodic table, and then the grams are given, mass given, you need moles, and we have direct relationship between, write the conversion factor, 1 mole of carbon over 12 grams of carbon, and then how many grams is given in your problem? It's given 0.02 265 grams of carbon. Grams of carbon cancel. If you divide these two numbers, you're gonna get a bigger number, like very small number, 0.00208 moles of carbon, right? You're gonna get moles of carbon. But how many sig fig number you need? You need 3, right? 1, 2, 3. And how many sig fig number you have in your answer? You have 3. 1, 2, 3. So you can leave your answer like this. That's also right. And you can also convert this number into a scientific notation, which will be 2.08 times 10 to the power negative 3 moles of carbon. Oh, the answer 0.00, you have double. Let me change this answer. I think I missed. So your answer will be 0.00. You have double 2, not single. 2208 moles of carbon. So your answer over here will be, you have 4 significant number, 1, 2, 3, 4, and how many you need? 3. You can convert into a scientific notation. Let me write over here. So we have, so now let's convert this thing into a scientific notation. So we have 2.208 times 10 to the power negative 3 moles, because we have to move the decimal from left to right. Then we need 3. This is 1, this is 2, this is 3. We don't need this one. So previous number will get increased by 1. So your answer will be 2.21 10 to the power negative 3 moles of carbon. So this is your answer over here. Correct answer, right? With a 3 sig fig number. So, so make sure you practice how to convert between moles and grams to moles, right? Back and forth. And then let's try. Let's go to this next one. And then let me do this problem. This is a little bit like bigger problem, different problem that we did. How many copper atoms are present in a penny weighing 3.10 gram, right? So how we normally do this thing. So what is required? You need atoms. What is given? Grams. Is there any relationship between grams and atom? No, there is no direct relationship between grams and atom. Grams is related with moles, if you remember this pathway. Mass, which is gram, related with moles, M-O-L, mole. And mole is related with atoms, which is Avogadro's number. 1 mole equal to 6.022. 10 is power negative 10 is power 23 atoms, right? So we have to use a 3 boxes solution map, right? So let's try to make a conversion factor between the first two. What's the relationship between mass and mole? We need mole, so I can write 1 mole of copper, because we are talking about copper. And what's the atomic mass of copper? 63.5 from periodic table. This is rule number 1. 1 mole equal to the atomic mass, copper. What should be the second conversion factor between the last two boxes, mole and atom? We use Avogadro's number. We need atom, so atom has to be on the top. 23 atoms of copper over 1 mole of copper, right? And once you made the conversion factor, multiply both of them and multiply with your given number, which is 3.10 grams of copper, right? That is given over here. So grams of copper cancel, moles of copper get cancelled. And when you solve this thing, you're gonna get around 0.29398 times 10 to the power 23 atoms of copper. of copper, right? And how many Sigfig number you need? You need 3, right? So this is 1, 2, 3. This one get increased more than 5, so your answer will be around 0.294 times 10 to the power 23 atoms. Or you can write this way too. So this will be one of the answer. Or the second you can write, you can move the decimal, you can write the same answer like this, 2.94 times 10 to the power 22 atoms. So both answer is right, are right over here. So make sure in your exam or quiz, you might get the bottom answer, even though the top answer is also right. It depends on the decimal, where the decimal is. Depending on the decimal, you will get a different exponent, 23 and 22. So don't get confused, right? So the coefficient or the exponent are different because we move the decimal, right? So similar, you might be getting a problem, right? If I give you atom, I can ask you how many grams if you have this number of atoms. So make sure we we did one problem which is going this way. I can ask you the same problem going backward, right? I can give you the atoms. You have to calculate the mass. So make sure you practice both ways, right? So yeah, okay. So let's go with the next one. So we already know how to calculate the molecular mass, like I said, right? So I'm not gonna go again. So now let's try to solve like a couple of problems on this molecular mass. Right? So calculate the mass of 1.7 mole for water. So you have to calculate the mass, and then let's try to solve this one. So if you have 615 moles and you need grams, again the two solution box, let me do fast. Mole to mass, and then I can write the conversion factor. I can say 18 grams water is equal to 1 mole of water. And we already know how I got this 18 grams, right? From the periodic table, 2 hydrogen, 1 oxygen is a molecular mass. And once you made the conversion factor, you have to just multiply over here 1.75 moles of water, moles for water, which is this. So moles for water get cancelled. And once you solve this one, you're gonna get around 31.5 grams of water. And it makes sense too, right? Your answer makes sense because 1 mole of water is 18 grams. And how many moles is given? More than 1 mole. So answer should be more than 18 grams, which is 31.5, right? So you can cross verify your answer too. So this is your answer. Okay. Okay. So this is the way. And let's see if you have other problem. So this is your homework, right? Make sure you practice. This is the same problem that we have, but you have to go opposite, right? How many moles are in 50 grams of PbO2, right? So this will be a homework. If you don't understand, send me an email or ask me in the office hours, right? So practice this problem by yourself. Now let's try to solve this problem. This is a little bit bigger problem. So let's try this one. What is the mass of this number of NO2 molecule? So in this problem, molecules are given. You have to tell me if you have that number of molecule, how many grams it will weigh if you put all those molecules on the weighing balance, right? So let's try to solve this one. So we have molecules. Why don't we have atom? Because NO2 is a molecule. That's why we are writing molecule, right? So let's make a solution map. So we are starting with molecule, molecules. right? We are starting with molecules. Is there any direct relationship between molecules and mass? No, right? If you remember the pathway, mass to moles to molecule or atom, or if you go backward, molecule to moles to mass. So mole has to be in center. You cannot pass through moles. If you have to go from one extreme to other extreme, you have to pass through mole. And then once you know the moles, you can get mass. Right, so everything depend on that solution box. If you remember that sequence, you can solve every problem. So now let's make a conversion factor. How molecule and moles are related. We know Avogadro's number, moles, and atom or molecule, right? So I can say 6 point. No, we need moles on the top over here. So let's do this one. So I can say 1 mole because we need mole over 6.022 10 is power 23. Let's do molecule of NO2, right? Of NO2. Second conversion factor will be mass and mole. What's the relationship between mass and mole? So I can say 1 mole of NO2 is equal to 46 grams of NO2. I hope you know from where I got this 46, because nitrogen atomic mass is 14. Each oxygen is 16. You have two of them, 32. 32 plus 14, 46, right? Which is one of the rule, 1 mole. Right? And then once you made this conversion factor, you have to just write your number, 4.78 times 10 to the power 24 molecules, right? So molecules of NO2, molecules of NO2 cancel, moles for NO2, moles for NO2 cancel. And then you have to just solve this problem, 4.78 times 10 to the power 24. When you solve this thing, you're gonna get around 36.5127 times 10 to the power 1 gram of NO2. But how many sig fig number you need? You need 3 sig fig number, right? Because 4, 7, and 8 on the top is 3 sig fig number. So this is 1, this is 2, this is 3, 4th is 1. So your answer will be 36.5 10 to the power 1 grams of NO2. So this can be one of your answer. Or if you have to convert this scientific notation into a standard form, you can write like this. So this will be one of the answer. Then if you have 10 to the power 1, if you open it, you will get 365 grams of NO2. This can be your answer too in standard form. So you have both the answer. Right? But the important thing is this solution pack. You need to know how to use these boxes, right? The pathway.